All right, small children, welcome to day 4 of our science note taking activities. Today we're going to be looking at minerals and specifically um, going into depth more about what minerals are and how to describe their physical properties. So by the end of class or by the end of this video, we should be able to explain what minerals are and how we classify minerals. And how we classify minerals would be describing their unique physical set of properties. So we go into it. What are minerals? Well, it's not like a straightforward definition. It's best to describe minerals by giving some characteristics here. First of all, they're non-living. So another way to say that would be they're inorganic. They don't come from living things. We don't get minerals from trees or plants or grass. Minerals are developed deep inside the earth through volcanic activity, and so they never were alive. Minerals are solid, so well, they're just not hollow. They're all solid. They occur naturally. They are not made in a laboratory by man. Minerals are natural forming. They have crystals inside them, or they're crystals. And the interesting thing about crystals is that crystals have a geometric shape to them. And that shape or that form repeats throughout the whole crystal. And that's one way to categorize a crystal too, is by its shape. And there's over 4,700 different minerals. So the world is chock full of minerals. And we see some examples here all around here. This is a geode. So you say, hey, Mr. Lesevich, you said they're not hollow. Well, the actual crystal, the actual mineral isn't hollow inside. They might be in a hollow part of a rock, but the crystal themselves is not hollow. All right. How do we classify minerals? Well, we do this by their shape, which once again, because minerals are a type of crystal, each crystal is going to have a slightly different shape. We do this by the hardness, and we'll see how you can test the hardness of a mineral. Luster. Luster means kind of how shiny it is. So you can look at different minerals, and some will be pretty dull, and some will be incredibly shiny, like it's been polished. But they haven't. That's just the way they naturally occur. Another way to classify minerals is how they break. Sometimes you can break a mineral and it's got a very smooth break to it. And then sometimes it looks more jagged. And then also we have what we call the streak, which we'll explain in a little bit. Alright, first of all, the shape. Minerals come in different shapes, but the shape is repeated over and over again. So in some minerals, like halite and galena, they come in a cube. The crystals form a cube, and they're cubed throughout any example you find. Then things like zircon and calciloprite, they come in more of a tetragonal, so that's more of a rectangular cube. And then we have quartz and calcite, which are more hexagonal in shape. Sulfur is more orthorhombic, which I'm not quite sure what that means. We'd have to look that up. Mica and gypsum is monoclinic, which is it's a little more slanted of a cube. So the shapes come in different. They come in different shapes, but it's repeated and repeated throughout the whole crystal. So if you or mineral, so if you were to break it, it would still be the two pieces would be in those general shapes. So this is important. So you need to be able to know that one way you tell the physical properties is shape. So write down that definition or that example there. Hardness. All right. Hardness is a mineral's ability to scratch another mineral. So the hardest minerals, like diamonds, can scratch everything. And then there's soft ones that can't scratch anything. And so there's a man named Mo who came up with a scale based on how other minerals can scratch each other. So there's talc, which is very soft. It's like chalk. You could scratch talc with your fingernail and it would leave a mark. Whereas you get to a diamond and it's the hardest known material to man. The only thing that can scratch pretty much a diamond is another diamond. So you notice also that these minerals tend to be sometimes very precious gems as well. And so these things are sought after. So a hardness, write this down, is a mineral's ability to scratch another mineral. And be familiar with the Mohs hardness scale. Just be able to know what it is, and not so much that you know how hard each mineral is. All right, luster. Luster is how minerals reflect light, but basically it's how shiny the mineral is. So you have things here like this is quartz. It's pretty shiny and transparent. They have a glassy luster. Some of these are opaque. It says opaque. It's kind of duller. But then you see some minerals that look metallic, like they're made out of metal. And so they're categorized in these three categories here. So for this, write down that luster is how minerals reflect light, and then write down the three categories: the metallic luster, earthy luster, and glassy luster. All right, here's some examples. This would be more of the earthy, and this would be more of the, that might be more of the glassy, and that's definitely metallic. I don't know what mineral that is. It sort of looks gold, but I don't think that's gold, but it looks very metallic. All right, once again, here's a glassy. This would be metallic. It looks metal. And this is the earthy. I think that might be copper. Copper tends to turn that kind of greenish blue. All right, how the minerals break. They break in two ways: cleavage and fracture. So you'll need to write this down, how they break, and the two ways they break are cleavage and fracture. So cleavage, the broken sides are smooth and straight. So if you look at little salt crystals, salt has a cleavage the way they break. They break in very smooth sides. Things like quartz would do this, and possibly sandstone. But then you have some fractures. Some ways they break are a fracture. The broken sides are rough and jagged. So the two ways they break are with cleavage and fracture. So here's an example of cleavage. The side is very smooth the way it broke. And this is fracture. It broke and it's very jagged. Once again, this is jagged with a little bit of a cleavage there, huh? This is cleavage because it's smoother. All right, streak. Streak is the color left behind when you rub a mineral on a white tile. And so that's important to write down. So sometimes the streak is the same color as the mineral, but not always. A mineral can be different colors, but its streak is always the same color. So it doesn't matter if the mineral itself looks red or blue, it's always going to leave the same color streak. Streak color is more useful than mineral color when classifying the minerals because the mineral color can change. You know, sometimes we have rubies that are different colors. Mrs. Lesevich has birthstone rings I gave her for each of our children's birth. And some of those stones that we have are the same stone but different colors. But if you did the streak test, even though they're different color minerals, the streak would be the same color. So that's what streak is. And you can say, you know, that would be very useful in identifying the type of mineral it is, because if it leaves a certain color streak, you know, no matter what color it appears to be, that the color of its streak identifies it. All right, I think that's, well, special properties here. There's just a few things about some minerals here. So calcite glows under a black light, and quartz can conduct electricity, so that's useful. All right, we'll stop there.